We want to graph y equals 3x squared minus 2. Here we can identify that the parent function from our list of basic functions is y equals x squared. This time we have this 3 that's multiplied to the x squared, and that's going to cause a vertical stretch of the parent function by a factor of 3. And finally, the minus 2 on the outside is going to cause everything to shift down by 2. Let's start with graphing y equals x squared. Y equals x squared passes through the origin 0, 0, then 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4. So here is our y equals x squared parent function. And a vertical stretch by 3 is going to cause all of the y values of these points here to triple, to get multiplied by 3. So the vertical stretch applied to 0, 0 isn't going to change anything because the y coordinate there is 0. But this point at 1, 1 is going to get stretched out to the coordinate point 1, 3. So it was the point 1, 1, and now it's going to get stretched out to the point 1, 3. So the y value is what is affected. And then over here at negative 1, that one's going to get stretched out to 3 as well. Now these points here at 2 and negative 2, those are also going to get stretched out by a factor of 3. So this 4 would become a 12, and this 4 would also become a 12, which go off of this xy plane. So we're just going to go ahead and leave these 3 points, and we're going to connect them together, and we can see how this graph has been stretched in a vertical direction to get y equals 3x squared. And then last but not least, everything is going to shift down 2 units. So we're going to have our vertex of the parabola down at 0, negative 2, and then these other points are going to move down 2 units as well. So they're actually going to return back to that 1, 1 and negative 1, 1. And we can connect those points together. And this is now the graph of 3x squared minus 2. Here we want to graph y equals negative 1/4 the absolute value of x minus 2. Our parent function here is the basic function y equals the absolute value of x. And then we have a few things going on here. So we do have a negative multiplied in the front of the function, which is going to cause a reflection over the x-axis. Then we have this number multiplied in the front of the function, so we consider the negative separate from the number. So the number is 1/4. And so since it's 1/4, which is less than 1, this is going to cause a vertical shrink this time. So in the previous example, when we multiplied by 3, it caused a stretch by 3. But if we multiply by a fraction between 0 and 1, that's going to shrink things down. So it's a vertical shrink by a factor of 1/4. And then we're going to have a minus 2 that's inside with the x, so it's going to cause everything to do the opposite of what you would think horizontally. It's going to move everything to the right 2 units. So here's everything that I have going on, and I'm going to tackle the vertical shrink by 1/4 first after we draw the parent function. So the parent function, the absolute value of x, is my v looking function, 1, 1, 2, 2, 3, 3, our coordinate points, and then on the opposite side, negative 1, 1, negative 2, 2, negative 3, 3. So here's my absolute value of x function. Now, I'm going to handle the vertical shrink part by 1/4. So all of these coordinate points here, the y values are going to get shrunk down by 1/4. So let's pick a nice coordinate point, like the coordinate point 4, 4, to focus on at first. So the x value stays the same. It's the y coordinate that's going to shrink by 1/4 or get multiplied by 1/4. So my new value that goes with the x value 4 is going to be 4, 1. It's going to be 4, 1. So we're multiplying the y value by 1/4. 1/4 times 4 is 1. And then the same thing would happen over here at negative 4, 4. We're going to have our new coordinate point be negative 4, 1. And 0, 0 is going to stay the same because the y-coordinate getting multiplied by a fourth just stays 0. So now here is my graph of 1/4 the absolute value of x. So this was a vertical shrinking, so kind of up and down it got flatter. It got closer to the x-axis. But if it's a stretch, if it's a number bigger than 1, it's going to get thinner and more narrow, closer to the y-axis. All right, so that's the new part, the vertical shrink by 1/4. And then let's go ahead and reflect everything over the x-axis. So that's going to take these points and 0, 0 will stay the same, but these other points are going to flip down. And so this is now my graph of negative 1/4 the absolute value of x. And then last but not least, we're going to move everything to the right 2 units. So the origin now moves over to the coordinate point 2, 0. This point right here at negative 4, negative 1 moved to negative 2, negative 1. This point here will move to 6, negative 1. This is going to be my final answer. This is negative 1/4 absolute value of x minus 2. Now all of these other graphs that are on here were just steps in the process of getting to the final answer. So if we want, we can go ahead and erase them so we can focus in on the final answer, which is just the one graph, the one v function that is flipped down below the x-axis, passing through the point 2, 0 as its vertex.